Good evening, students. Am I audible?
Yes.
Okay. So we'll get started. So what was the last topic we saw? We saw the free body diagrams and we were doing some examples, right?
Yes, sir.
Now we will start with the next topic, that is friction. So we are going to deal with the next topic, which is called as friction. Now, the question is, what is friction? How will you define it?
Sir, I think it's the equal and opposite force which resists the force against the moving body.
Okay. So you're trying to say it is a resistive force, right?
Yes, sir.
Okay. Suppose I have a fixed surface like this, on which there is a block placed. And let's say the block is of mass m, and the force that you're applying is F. Okay. Now, yesterday we solved some problems where the surface was smooth. Now, if I consider the surface to be rough, means if there is friction present in it, okay, with friction, if I consider, then let's say if this force is not sufficient enough and the object is not able to move, you started applying force, okay, but you're saying that this object is not able to move, then what will you say is the reason behind it? Then can I say that the force, that is the external force applied, is less than a force that is stopping it, which we call it as friction? Okay, maybe this is what you have learned in your lower grades. Now the question is, so there are many questions that are coming in my mind. So if you're saying there is something called as friction which is existing, which is a resistive force, then how does it act? And what exactly does it do? And the third question is, which surface offers? Fourth is, what is the reason behind its origin? Or what is the reason behind its existence? How is it able to exist? So all these questions need to be answered. Right. So for that, let me take another scenario. Suppose you have a table on which, let's say, you have a stack of books. So let's say you have a stack of books like this. These three are books. Okay. Now, let's say this is your math, this is your physics, and this is your chemistry. So they are kept like this. You have arranged it in this way. Now, before this class, you wanted to pull this book outside. Right. So when you pull this book outside, tell me what will happen to your math book and what will happen to your chemistry book. So I'll give you options. Physics book alone comes out. So physics book alone comes out, and once this book is taken out, will this be the scenario? So did you understand what I drew?
Yes, sir.
So what did I say? I'm saying that once the physics book has come out, your chemistry book will exactly fall on top of your math book. Is that what is going to happen? Or something like this would have happened. What do you think would have happened?
I think the second one would happen.
Option.
Why? So not the first one? For sure, not the first one.
No, sir. I think because due to like when you take the object with high speed, then the book falls exactly inside.
Very good. Very good. It's a very good observation. What you told is perfectly right. Okay, but when you pull it slowly, what will happen?
The chemistry book would fall along with the book in the middle.
The chemistry book will actually try to travel back.
Sir, would the chemistry book come out with the physics book, sir?
Sometimes it can happen depending on what force you're pulling with. Okay, so sometimes this can also happen. You're trying to say this will happen, right?
Yes, sir.
Yeah, this can also happen. Depends, completely depends. When I say completely depends, on what factor does it depend? Means the nature with which this book is made, the nature with which your physics book is made, right? See, for example, you guys have your textbook, right? You have your NCERT textbook. You know the feel of it, right? So how does the NCERT text? Is it a laminated one? Do you have a shining glossy paper on top of it? When you go to, do you have it or not? Please answer that question.
Yes, sir.
Kind of shine.
It's kind of shining, but if you touch and see, it will be rough, no? Right? Suppose you try to get some other book. Let's say your class notes. Let's say you're using a classmate book. Okay, they're slightly costly, so you'll find the lamination on top of it, right? Lamination in the sense it will be slightly smooth compared to, you can touch both the books and see. Are you able to understand what I'm trying to say? Are you able to sense?
Yes, sir.
Feel
Yes.
it? Yes. So now the question is, it purely depends whether this scenario is going to happen or this scenario is going to happen on what kind of books are on top of each other. Okay, but our interest is not about whether the second scenario is going to happen or third scenario is going to happen. Definitely, we understand that the first scenario is not going to happen, because in realistic situation, this will happen only when, like someone told, like when you pull the book with a greater velocity, then this chemistry book will fall immediately, because you are not giving enough time for friction to come into picture. Okay, that is actual reason or actual physics behind it. Now let's try to understand. So why I put all this example is because I wanted to give you a different perspective. Generally, what will happen if I ask you to draw a free body diagram by showing friction? By default, everybody draws that friction is an opposing force, right? But that is a misconception. Friction will not oppose every time. It will sometimes support also. Okay, so that is what we need to understand. So friction, if it has to be called, the general meaning given to it is it's a resistive force. Okay, it is a resistive force accepted which tries to oppose the relative motion. This very important term, relative motion between two surfaces in contact. So this is the meaning, guys. Please write it down and explain what it is. Okay, let me explain what it exactly means. Let's see what is the science involved behind the stack of books which I was telling you. Let's say this book is there, no? What book is this? It is a math book. Right? Now, observe, when you apply the force on this physics book, you're applying the force like this, right? Now, I am assuming this surface is rough. I am assuming this surface is also rough. Means there is a friction that is existing between the physics book and the math book also. So the force is applied directly to the physics book. Now, if I take the surface, the boundary that is connecting the physics book and the math book, then how is my free body diagram going to be with respect to the physics book? Observe, no? So when I apply the force on the physics book in this direction, what do you think is the direction in which the frictional force will come into picture? What do you think is the direction in which the frictional force will come into picture on the physics book? Will it be in the direction of force
Minus
or
F, sir.
it will be in the direction opposite to this applied force, right? So if I call this as F, then what is the subscript I'm supposed to write? This is the frictional force exerted by the physics book on the math book or math on physics.
Physics on maths.
It is actually the force exerted by the math book on the physics book. Because the top surface of the math book is also rough now. You're able to understand? But I have an important question to ask. When the math book is able to, so is this point clear? Is anyone having a confusion? Am I clear, guys? Shall I
Clear,
proceed?
sir. Yes.
Clear, right? Okay. Okay. Now, if I take the math book alone, if I say that the math book is at rest, right? That is what you're able to observe. Right? You can observe that the math book will still be at rest only. Why is it happening? Why is it happening? Because this force exerted by the math book on physics is there, no? Then this will be the direction of frictional force exerted by the physics book on math. You're able to understand what I'm trying to say, guys? Means friction doesn't exist as a single source. It exists in pair. Where if I call this as the action, then this is called as the reaction. So friction always exists as an action reaction pair. Are you able to understand till this point?
Yes,
Am I
sir.
clear? Right. Now my diagram is not complete because the top
The
part
floor is also exist.
Very good, very good. Because there is a math book is in contact with the floor also. So if this FPM alone would have acted, logically what should have happened? When there is an unbalanced force, according to Newton's first law,
Math book also should have moved.
Math book should have also moved, but you're observing that it is at rest, then there is some other force which is not visible to our eyes that is existing. What is it? It is the frictional force exerted by the floor on math book. Are you able to understand this? Are you guys able to visualize it? See this point, you need to understand to solve problems, or else it is going to be like you'll just mug up the formula and write it, which is of no use. Am I clear, guys? Am I clear with this point? Now
Yes,
the question,
Yes.
this math book is in contact with the floor, right? Then what is happening? Then this math book will exert a force on the floor in the rightward direction, which is FMP. But what will happen is you cannot make that floor move because it is held internally by many other forces. Am I clear? So if you try to break down the whole process, this is what happens. So again, Here also, if you observe, FPM and FMP are action reaction pairs. Now, are you guys able to understand what is the meaning of the word relative motion? I'm using the word relative motion because friction will always try to oppose the motion of one object with respect to another because of these action reaction forces. Clear? Please let me know if there is any doubt. This is the important point I wanted to register. Am I clear, guys?
Yes, sir.
We'll move on to the next point now. So we understood what is friction and how friction will act. So friction will always exist as an action reaction pair. So if you need to say any force as an action reaction pair, action and reaction should be on two different objects. They should not be on the same objects. For example, you cannot say this as F and FMP are action reaction pairs. No, because it should be the same nature of force. The same force, same nature of force should act on two different objects in two different directions. Then you call it as action reaction pair. So if somebody asks you, is friction an action reaction pair? You need to say the answer is yes. Okay, now. Now the next important question that comes is, why does friction come into existence? Why is friction coming into existence? Anybody? It has
Because of
something
the
to
rough
do.
surface, sir.
Yes, rough surface is okay. Due to the rough surface, what property, what molecular property of the rough surface is coming to picture, due to which you are saying friction is existing? So when you say it,
Irregularities.
sorry,
Irregularities.
that is the word. Because if you look on a microscopic level, what will happen is this is what is a rough surface, but to our eyes, it will appear as if it is a smooth surface. Right? For example, you see tiles or marbles, everything will appear like a smooth surface, but there is some interlocking that is taking place. Right? So there will be some irregularities that are present on each surface, due to which there will be an interlocking taking place. So I hope you understand what is the meaning of interlocking. So locking is they'll get log intermins between two different objects. Right. So interlocking takes place, due to which the friction will oppose the motion of objects. Clear? Having all these points in mind, we are going to start deriving the mathematical expressions for what is a friction. Before that, we need to understand the different kinds of friction, the different types of friction. Any idea, guys?
Static friction, sliding friction, or rolling.
Very good. Static, kinetic or sliding, and the third is rolling. So what do you mean by static friction? So the frictional force that comes into play when the object is at rest. So the frictional force that comes into play when the object is at rest. Kinetic friction is that friction which comes into picture when the object is in motion. Correct? That is when it is sliding. What do you mean by sliding? Sliding is translatory motion. So what kind of motion I'm trying to talk about here is translatory motion, and rolling motion will come into picture when the object is in rolling motion. Now, so if I take this surface, guys, if I say the frictional force acting is F and the object has mass M, then mg is acting in this direction, normal force is acting in this direction. So should I write that the frictional force depends on weight of the object, or frictional force depends on the normal experience by the object? Which one is right among the two?
Sir, it
mg,
depends
sir.
on weight.
So you're saying friction is directly proportional to mg, right? But that is wrong, because weight or mass decides the inertia of the object. Okay, especially mass decides the inertia of an object. So we should not write F is directly proportional to mg, because friction is the force offered by the floor. Mg is the property of the object. Whereas I can say friction is offered by the floor and normal force is also offered by the floor. So that is why we should always say friction is directly proportional to the normal force. It is not proportional to mg. This is a very big misconception that people have. Okay. So if I take that into consideration and write, I can write F is equal to mu into N, where this mu is given a name called as coefficient of friction. So we call it as coefficient of friction. F is equal to mu into N. So depending on the three scenarios, there are three kinds of frictional forces that we can define. Fs is called as static friction, which is equal to mu s into N. Fk is called as kinetic friction, which is also written as mu k into N. Fr is rolling friction, which can also be written as mu r into N. Okay. Now I have a question, guys. Out of these three, which one do you think will be the greatest?
Static friction.
Static
Yes.
friction.
So static friction is the greatest. It is greater than the kinetic friction is greater than the rolling friction. Okay, this is the order, but we need to think of the logic also. Why do you think the static friction more powerful or more stronger than the kinetic friction?
The interlocking of the objects will be higher.
Will be higher because the object is at rest. Whereas when you talk about kinetic friction, the interlocking will be less because the object is in motion, means you're not giving sufficient time for the objects to get locked. Whereas when it comes to rolling friction, what can you say? The interlocking will be even more lesser because the size
Surface
of
area
the
is less.
yes, the surface area that is coming in contact is going to be less. Okay. So in static friction itself, I need to explain a term called as limiting friction. Limiting friction is represented by the symbol F with the suffix L. Now I'll explain it in this way. Let's say there is an object of mass 2 kilogram present on the surface. Okay. And let me say the coefficient of static friction is 0.5. Okay. Then tell me what is going to be the value of static friction according to the formula mu s into N, right? So what is the value of mu s? 0.5 into what is the value of N, guys? You can take G as 10. You can take G as 10. So N will be equal to mg, that will be 20. So if I take it as 20, then I'll get the answer as 10 Newton. What is this? This is the amount of frictional force the surface can offer. Correct? Now tell me, guys, if I apply a force of 1 Newton, will this object move? Do you think this object is going to move if I apply a force of 1 Newton?
No, sir.
No.
Why? Why? Because
The force of friction is greater there.
To
so
overcome
static friction is 10 Newton, right? Have this in your mind. So static friction is 10 Newton, but I have an important question here. When you applied this 1 Newton force, how much will be the value of the static friction that will come into picture? Is it going to be all the 10 Newton that will come into picture, or is it going to be only 1 Newton that will come into picture?
1 Newton.
Think
Sir.
of it will only be 1 Newton. Why?
Equal and opposite force.
That is one reason. The main reason is when you apply an external force of 1 Newton, it is already having 10 Newton, right? Its maximum strength is 10 Newton. But it is saying I need not exhaust myself. If I apply an equal force on it, I'm just going to stop it, right? Because I know that there's only 1 Newton that has come into picture. Now, if I increase it to 2 Newton, how much will come here?
2 Newton.
If I increase it to 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, till where? So if you apply 10 Newton here, then here how much will be the force that will come? Here also it is going to be 10 Newton only. But when is this object? So is this object going to move in this scenario? The acceleration on this object
sir.
is still 0. Whereas if I apply a force of 10 point, even this much amount of force is going to come into picture. The maximum frictional force that the surface is able to offer is only 10 Newton. It can't go to this value because its maximum value is exhausted. It will give up. All right. So what is happening? Depending on the external force you applied before the object starts under static conditions, depending on the value of the external force you applied, the static friction adjusted itself. The static friction adjusted itself. That is why static friction is also called as self-adjusting force. Am I clear, guys? So static friction is also called as self-adjusting force. Okay. Now the question is, you can ask me. Tell me.
Sir, so would the object move if it is 10.0001?
Yeah, now it will move. Now acceleration is not equal.
Okay, sir.
Okay, why is it moving? It is because now there is a difference. Now there is an unbalanced force acting. It will start moving. Okay. So static friction is a self-adjusting force, and the maximum static friction that you're trying to talk about is what is called as limiting friction. So as the name suggests, limiting means it is the maximum value. So limiting friction is nothing but the maximum static friction which we need to overcome to make the object move. Or you can put it like this: the maximum static friction offered by any rough surface is called as limiting friction. So only after you apply a force greater than the limiting friction, you can expect the object to start moving. Okay. Till then, what will it do? It will keep adjusting itself. It will keep adjusting itself till you reach the maximum value. Clear, guys? Okay. So to put it in very simple terms, we need to understand what is friction. We need to understand how to draw the free body diagram. I'm sure you guys would have understood with the example of that math, physics, chemistry book. And the only formula that is there for friction is F is equal to mu into N. Depending on what is the nature of the friction, you just substitute that parameter. Okay. Now, I will try to explain few examples. So they have given it to us. Example 5.7, let's see. Determine the maximum acceleration of the train in which box lying on its floor will remain stationary, given the coefficient of static friction between the box and the train's floor is 0.15. Did you understand what is the question? So there is a train there. in one of the compartments, there is a box lying like this. Okay, let's say it is a goods vehicle, and there is one box. Let's say it is of mass M. Let's say it is of mass M, which is lying on its floor and will remain stationary. Okay. Given that the coefficient of the static friction between the box and the train's floor is 0.15. So the train's floor is rough and it can offer a static friction of 0.15 Newton. Sorry, 0.15. Mu is a dimensionless quantity. I'm sorry. So coefficient of friction doesn't have any units or dimension. Now, if the strain is accelerating, okay, if the strain is accelerating, what do you think will be the acceleration of this block? So for a person standing here and seeing, when the train is accelerating and this box is going to stay at its place, then can I say that the acceleration of, then the force experienced by this object is m into a?
Yes, sir.
Right, where m is what? M is not the mass of the train's compartment. It is the mass of the block. Okay. Then they are asking what should be the maximum value. Means the force that the acceleration with which this train is going to move should be in such a way that it should be less than or equal to the limiting friction. Why did I use less than or equal to? Because I know static friction can adjust itself. When will the object not be, when will the static friction fail to adjust itself? When it touches the limiting value. So what is going to be the limiting friction, guys? It is mu s into n. So MA should be less than or equal to mu s into n is m into g. Now m and m can be cancelled. A will be less than or equal to, what is the value of mu s? 0.15. If I take g as 10, so A should be less than or equal to 1.5 meter per second square. Means if the train is moving with an acceleration of value less than or equal to at the max 1.5 meters per second square, that block will remain stationary. Or else what will happen? The block will go and hit this wall because it would have overcome the frictional force. Clear? Next. So example 5.8, see figure 5.11. The mass of 4 kilogram, a mass of 4 kilogram rests on a horizontal plane. The plane is gradually inclined until an angle of theta is equal to 15 degrees with a horizontal. The mass just begins to slide. Means it starts experiencing an acceleration which is not equal to 0. Then if this is the case, what is the coefficient of static friction between the block and the surface? Okay. Now they are saying, see, one correction I would like to make in the diagram is whenever you're drawing this frictional force, no, draw it along the surface. Okay. Means if you draw the free body diagram, yesterday itself I told you that if theta is the angle of inclination with respect to the horizontal, then this component along the inclination is mg sine theta, and this is the static friction. All right. And how much is the normal force, guys? Normal will be equal to mg cos theta. Am I clear, guys? So what is the value of Fs? Fs is equal to mu s into n. Mu s into, what is the value of n? What is the opposite force to n?
mg cos theta.
Very good. It is mg cos theta. Then can I say that mg sin theta should be greater than, or I can say mg sin theta should be slightly greater than Fs. So the maximum value is mg sin theta should be equal to Fs. So it become mu s into mg cos theta. Mg and mg will get cancelled. Tan theta will be equal, tan theta will be equal to mu s. So they asked us to find the coefficient of static friction, right? So this is the value. So mu s is how much? It is tan of 15 degrees, but you know how to solve tan 15? It is tan of 45 minus 30. Tan A minus B is tan A minus tan B by 1 minus tan A tan B. Applied, you will get the answer. Okay. So this angle at which, this angle of inclination with respect to the horizontal at which the object starts sliding is called as angle of repose. So what is the angle of repose, guys? The angle made by the inclined plane with the horizontal at which an object just starts sliding by overcoming what? By overcoming the frictional force.
Sir,
Please tell me.
sir, why is mg sin theta equal to static friction?
Mg sin theta should be slightly greater, just greater than. See, if mg sin theta is 10.00000000, 10 zeros and 1, and frictional force is 10, what I did is I approximated this value and this value. That was just before the object started sliding. Read the question. Our intention is not to find the acceleration. Our intention is to find what should be the, at this angle of inclination, when will it just start to slide? It will be able to slide only when the frictional coefficient of friction is this value. That is why I equated.
Yes, sir. But it should be greater, slightly
It
greater.
should actually be greater. It should be greater, but the value of but the greater value will be in such a way that it approximately be equal to that value. So if I have to write it in a correct way, then I have to use an approximate. Okay. So please make a note. I hope you guys are clear with this word angle of repose, right? So angle of repose means what? The angle of inclination with the horizontal at which what will slide? The object will slide on the inclination by overcoming what? By overcoming the frictional force. Okay. Shall we go to the next one, guys?
Yes, sir.
Listen, let me copy this, just a minute. So what is the acceleration of the block and the trolley system shown in the figure 5.12a? If the coefficient of kinetic friction between the trolley and the surface is 0.04, and what is the tension in the string? Neglect the mass of the string. Okay. We'll get started. See, if you observe, these kind of problems are, you need to deal it in 2 dimensions. Because there is a block which is moving in the y direction and there is a trolley which is moving along the x direction. Okay. So how many objects are there? Read the question. They are asking what is the acceleration of the block and the trolley system. So block and the trolley will have the same acceleration. Why? Because they are connected with the help of an inextensible string. Okay, now the question is, how do I draw the free body diagram? If I take the 3 kilogram block, then 30 Newton is acting in the downward direction and tension is acting in the upward direction and its acceleration is acting in this direction. Can you tell me the Newton's, can you apply Newton's second law in this case and tell me See, you need not sit and find out the directions and all. I'll tell you a simpler way. Yesterday, the algorithm that I gave you, since you're doing it for the first time, but a more mature way of doing is look at the direction in which the acceleration is there. So, in whichever direction acceleration is there, take all the forces in that direction as positive. The opposite direction will be negative. So, what should I write? 30 minus t is what is causing the acceleration to the 3 kilogram block. Did you apply? Did you understand what I did? Sum of all the forces is equal to mass into acceleration. So 30 minus t is equal to m into a. Okay. Similarly, what is happening here? For the trolley, tension is in this direction. Frictional force is in this direction. And what is the weight of the trolley? Mass of the trolley is 20 kilogram. Yeah, 20 kilogram. So what is the weight of it? It will be 200 Newton. And there will be a normal force acting in this direction. Right? So this direction is the acceleration, guys. Now you people tell me the equation. When you apply Newton's second law, how should you write the equation in one step? T minus T minus Fk is equal to mass is 20 into acceleration. But T minus, what is the value of Fk? It is mu k into n is equal to 20a. So T minus, what is the value of mu k? 0.04 into m into g. M into g is 200 is equal to 20a. So T minus 8 is equal to 20a. Let me call this as equation number 2. Let me call this as 1. So when you solve both, what do you get? 30 minus t is 3a. T minus 8 is 20a. Solving both, we get t and t getting cancelled. 30 minus a is 22. 22 is equal to 23a. Acceleration is 22 divided by 23, which is approximately 1, but it should be something like 0.9 something. Because 22 by 23, 23 by 23 would have been 1. It will be a value slightly less than that. They asked what is the acceleration. I hope you got the answer, right?
Sir,
Tell me that.
sir, I have a doubt, sir. Sir, this trolley has wheels now, sir. So it should be rolling frictional water.
No need, no need. See, the story is like it is. They didn't mention anything about the wheels. You will take that rolling motion into consideration only if the wheel is of considerable size.
Oh, okay.
See, for example, what I can say is, let's say that wheel is only a showpiece where it can't rotate. Then what would have happened? It will slide only, no?
Okay, sir.
So that is a scenario. Yeah. Shall I move on to the next one? Next part. They asked, what is the acceleration of the trolley and the block? What is the tension in the string also we need to find. So how to find the tension? Take this acceleration, substitute it here, you will get the tension. So T minus 8 is equal to 20 into 9 is 18. Right? Sorry, 20 into 0.9 is 18. So T will be equal to 26 Newton. It's an approximate value. Done, guys?
Yes.
Yes. We'll solve some more problems based on friction. Next class, we will see how this friction supports circular motion. Not many problems based on friction. Can I do a slightly tougher problem? Okay. I'll give you a problem on my own. Let's say there is a 20 kilogram block here. There is an 8 kilogram block here. There is a pulley in between, and there is a string that is going in this way. Okay. Let's say this angle is 30 degrees. And let's say this angle is 60 degrees. Okay. So let's say the coefficient of friction is 0.5. Coefficient of static friction. Okay, we'll take it as kinetic friction. So the coefficient of kinetic friction is 0.5. We need to find what is the acceleration of these blocks. How to do that? So let's say both the sides are rough. This side is rough and this side is also rough. Okay. How to do, guys? So if I take the 20 kilogram block, tell me what are all the forces acting on it. There will be a force
sin theta.
That is, I'll take G as 10 only. Mg is 200 into sine theta is how much?
30 degrees.
So sine 30 degrees. So can I say this is 100 Newton? Right. Similarly, if I take this 8 kilogram block, what are the force acting this side? 80 into sine 60. That will be 80 into root 3 by 2. It will be 40 into root 3. So 40 into root 3 is less than 100. So the objects will move in this direction. This will have an acceleration in this direction. And 8 kilogram block will have an acceleration in the upward direction. Is it clear? Now, there will be a tension acting in this direction. And there will be a tension acting in this direction. They both are of same value because it's the same string. So in a given problem, the number of strings is equal to the number of tensions. Any doubt till this point?
Sir, why sin 30 and sin 60, sir?
Because mg sin 30, no? This is the theta. For this, if I look at it like two inclined planes, if I look at it like two inclined planes, then this angle will give us mg sin 30 here. And this one will give mg sin 60 because the angle of inclination is 60. Clear or not?
Okay, sir.
When should we use cos, sir? Mg cos theta.
It is when you take it in this direction.
Oh, okay, sir.
That will be 200 cos 30 and this will be 80 cos 30. Okay. Here let me call it as N1. Here let me call it as N2. Are you clear with both the free body diagrams?
Yes, sir.
I missed something to draw in the free body diagram. Correct it?
Sir, kinetic friction.
Very good. I didn't draw friction at all, no. See, when the object is accelerating in this direction, here the kinetic friction will be in this direction. And here the kinetic friction will be in this direction. Right. Now see, now you guys tell me the equations. When the acceleration is in this direction, I told you the forces in the direction of acceleration can be taken as positive. So 100 minus what are all the forces acting in the direction opposite to axis? T and Fk. So the resultant of all these forces is what is causing the acceleration on the 20 kilogram block, that is 20A. Using the same logic, tell me how to write the equation for the second one. Guys, tell me for second one.
Sir?
For this one, how to write the equation?
Sir, in the second one, sir, the object is accelerating
in this direction.
Oh, okay, sir. Okay.
So tell me, T. Okay, I'll slightly reduce this confusion. This 80 sine 60 is 40 root 3.
So T minus 40 root plus Fk.
Plus Fk, very good. Should be equal to?
So 80.
That's it. Okay, that's it. So you add both, what will you get? T and T will get cancelled. 100 minus 40 root 3 minus 2 times Fk is equal to 28A. Fk, you can find it. So 100 minus 40 root 3 minus 2 into what is the value of Fk? It is mu k into n, which will be equal to 28 into A. So 100 minus 40 root 3 minus minus 2 into mu k is how much term? 0.5 into n is sorry guys. 1 minute. Both Fk's are not of same value because here it is 0.5 into n is 200 cos 30. That should be equal to 20A. Similarly, tell me what will be the value of Fk here?
0.5 into 80 cos
30.
80 cos 60. Sorry, 80 cos 60 should be equal to 8. Now, this will make more sense. Minus 0.5 into 200 is 100. 100 cos 30 minus 40 cos 60 is equal to 28A. One unknown, one equation. You can solve this, right? So anyways, this is a slightly tougher problem, but I'm happy that you guys could answer it. So you understood how to frame the equations, right?
Yes, sir.
That's it, right? That's a simple logic. Okay.
Sir, in the second case, second
Tell me.
object, the diagram it is given like accelerating towards upwards, sir. So in the first one it is given like accelerating downwards.
Yes.
So, but it should be in practical sense, it should be in opposite direction, right, sir? That one, like that.
Now tell me. See, it would have been in opposite direction if it had been an elastic material. but here it is inelastic, no? Means this force, whatever is there, it is taking, so this block is actually being pulled by this force. By overcoming the friction and all those things, you're able to understand. That is the reason why I took the acceleration of the 20 kilogram block in this direction and acceleration of the 8 kilogram block in exactly same direction, so that when you join them, no, they will move. So this is also moving along the inclination. This is also moving along the inclination.
Okay.
Are you able to understand what I'm trying to say?
Since it's inextensible, it is moving along the same
Yes,
direction.
exactly. Only when it is inextensible, you can say that both the objects have the same acceleration. Else, it cannot have.
Okay.
Okay. So that's it, guys. So this is all about friction. In the next class, we'll discuss about friction in the application of friction in roads. Okay. That's it, guys. There is no doubt we can wind up.